Good morning, good afternoon, or good evening, depending on where you are in the world. Welcome to EE World's Engineering Training Days. EE Training Days is a series of webinars where we discuss all things related to electronics. Today's session is the rise and future trends of edge computing and AI, sponsored by Advantech and with help from Hailo. I'm Senior Technical Editor Martin Rowe. I will be your moderator today. This session, we're going to have a few slides, but mostly it's going to be an open discussion. So feel free to ask questions in the Q&A, and we'll be ready to go. And just a little disclaimer: I am dealing with COVID, so I may blank my camera like that from time to time as needed. Hopefully not. But just in case, if you see that happen, that's me and not you. So as I said, we will have some slides. The slides will be available on demand at eetrainingdays.com, as well as other resources we will also have available. So we will have a few slides and then a Q&A. Our speakers today are Charlie Wu, Associate Director of Product Management at Advantech, and DC Smalley, General Manager of North America at Hailo. So DC, you had a little bit to say first, so why don't you go?
All right, sounds good. Thank you very much, Martin. So I'm DC Smalley, the GM for North America at Hailo. So I'm handling our sales and application engineering and go-to-market in North America. Happy to be here. So yeah, we're gonna talk a little bit about the types of edge AI, starting out with the types of AI that, at least in the Hailo nomenclature, that we identify in the market today. So starting with this slide here, this is sort of the evolution of the different types or categories of AI. And I'm not talking about artificial general intelligence. We'll leave that for sci-fi, hopefully, or a few years down the road. But real practical types of AI that we see in the market today and that we're supporting with products and technology. So starting at the left, perceptive AI. This is kind of the most common type of AI that we see in practice in the industry today. This is looking at a scene, looking at a video typically, and getting an understanding of what's in the scene, who's in the scene, where are they going, what's happening, so that you can make determinations about what you should do. So, for example, if you're in an automated car, you're in an autonomous driving car, you are perceiving the environment around you, understanding the trajectories of the objects around you, and making determinations from there. This is like I said, this is the most common type of AI that we're seeing in practice today. It's generally sort of video driven, so it's making these determinations from video data, and it's really about taking a lot of data and distilling that down into a smaller amount of data. So, for example, if you're looking at a scene, a video scene, you're taking a lot of video data and you're distilling that down to something that is an understanding of what's going on in that scene. So it's sort of a data reduction actual process in perceptive AI. Next, we have enhansive AI, which is a little bit more, I think, of a Hailo nomenclature. But what this is doing is really using AI techniques to improve or impact the content itself in the video. So this is about content beautification, perfection, basically improving the quality of the video through things like denoising, in particular doing denoising at very low lighting, image stabilization, auto exposure, things that can normally be done through typical ISPs or other image processing techniques. But when you apply AI and semantic awareness, the understanding of what's in the image, you can do this more sensibly and you can get better results in terms of low light performance, for example, or other aspects of the image quality can be optimized through AI. This is not really increasing or decreasing the data that's in the scene. This is about improving the data that's in the scene. And on the right-hand side, this is getting all the hype these days. This is generative AI, which I'm sure most of the users know about generative AI. This is content creation. This is things like Llama, Chat GPT, Stable Diffusion. So creating language, creating text, creating graphics, creating video in the case of things like Sora from a smaller amount of data. So this is actually, as its name implies, generating data from a small amount of data like a prompt and creating a scene, creating natural language, etc. So these are sort of the three categories of AI that we see today. And all of these are actually, or can be used in conjunction with one another to sort of optimize what you're trying to do in a given system. For example, enhansive AI, if you first beautify the scene in terms of taking out the noise or improving the image quality, you can also get better analytics from that scene. So some of these, there's definitely an intersection across all of these types of AI, but it's important to understand, I think, a little bit about the distinction between the three types of AI. And what we really want to talk about is why is and what kind of AI are moving to the edge and why. So first, what is the edge? What do we mean by the edge? In the simplest terms, the edge is the furthest most point closest to the object that you're detecting or the scene, etc. So this could be as close to the edge as the actual camera sensor, right? So we can run AI workloads directly at a camera. That's about as close to the edge as you can get. And then on the flip side, you've got data centers, right, which are typically training models, right, or serving up websites. And so this is the furthest most away from the edge. And now, as you get in between those 2 points, there can be different opinions on if it's edge, fog, and cloud. There's different terms, but in the simplest terms, think of edge as the point at which you want to make a determination, and the cloud, the point at which you're training the data to be able to make those determinations, which are then made at the edge. So now, why would AI be moving towards the edge, right? So, Hailo is an AI chip company. What we focus on is inference at the edge. And so what we're seeing is a huge evolution of the types of AI that can and should be run at the edge. And these are some of the reasons why we are seeing this movement to the edge with AI. So the first is real-time insights. Anyone familiar with autonomous vehicles, Teslas, for example, you know that reducing latency, enhancing the user experience is critical. So for example, if you are using video to make determinations about the person that may be passing in front of your vehicle, you can't wait for that scene to be transmitted up through multiple points in the network back to the cloud, processed. So the cloud determining, is that person passing in front of the car or not? And then routing that information back to the vehicle through several hops. It's too much latency. The user experience, especially if you're the person passing in front of the car, is going to be terrible because you're going to have too much delay, and you can't tolerate that kind of delay in many systems, many embedded edge systems. Tesla's just one example. There's a lot of cases where you need to process immediately. Sort of similar to the real-time insights or availability. A lot of the applications that we see at the edge today do not have the luxury of relying on a constant Wi-Fi or 5G access to cloud, to the network, to the Wi-Fi. There are applications such as if you're monitoring a train track for somebody who might pass in front of it. I think that anyone who has been on a train or seen train tracks knows that many, many miles of train tracks are in areas that are very rural with no connectivity. So you need to be able to run these analytics, make these decisions, determine what you need to do at the edge without having to rely in many cases on Wi-Fi access back to a cloud to make the determination. So availability is critical in many of these applications. And then you move on to high accuracy. Again, this sort of follows from availability. And again, as I talked about, a lot of the use cases around AI are relying on video data to supply the information needed to make some determinations. And as we also know, transmitting and processing video data can be extremely bandwidth heavy on the network and costly, especially if you're paying for the ingress and egress of your data in a data center. So what typically you could do is reduce your data rate by either reducing the resolution of the image that you're taking in, or skipping frames and reducing the frame rate of the data that you're taking in. In both of these cases, what you're doing is you're throwing away data that you could have otherwise used to make determinations on what is happening in that scene. And therefore, you are reducing the amount of data that you can use to make solid claims about what you see. So you can therefore increase your false alarm or misdetections in certain applications. So if you can process all that at the edge, you don't have to reduce the resolution or reduce the frame rate necessarily before pushing it up to the cloud. Instead, you're processing it right at the edge. You can increase your accuracy rate and reduce your false alarms or misdetections. And the last, the last of the four may be the most important or is the most important for many applications, and this is improved privacy. A common application is something like, for AI, is detecting if you have like in a hospital situation, if you have a patient, you need to detect and make sure, that they're getting the proper care, and you need to feed that information through a hospital system. You don't, or you can't, in many cases, transmit that very private data up to the cloud to be worked on by AI in the cloud. So instead, if you process this directly at the edge, you can use a lot of techniques not to, either to shroud the person's face or not even transmit that information, keep it all within the local cloud, but still get very effective detections and so forth on this data. So it's a way to significantly improve the privacy of the data and the people that are in the scene. So this is why AI tends to move to the edge, and why we've seen such a huge transition from running all the workloads at the cloud to now we're seeing many of these workloads running at the edge. And they can be running on a variety of different technologies as well, right? We know that there's CPUs that can be used to handle certain AI workloads. CPU, central processing unit. It's an amazing general purpose processor, but at its core, the way a CPU is architected, it's about central processing. And if you look at the way that AI and the types of AI models are structured, they require a lot of parallel updates to connections and to weights in an AI model. An AI model is filled with connections and weights. It's a very parallel type of processing. So a CPU can get bogged down by the fact that it is a very central processor. It cannot handle these updates in a parallel fashion as well. So it can not handle as sophisticated an AI workload as something that's been built for AI. And that's where something like a GPU can come in. A GPU is an amazing general purpose sort of brute force way to apply what was a graphics processor. I mean, that's what a GPU is. And what a GPU adds is the ability to do parallel processing very quickly. It's a high bandwidth type of processing. And so GPUs do offer a really good way to enable AI workloads, but they're not really optimized for the power and the efficiency at the edge. So they're not necessarily optimal in all cases. You also have FPGAs, which can be similar. They have a lot of parallel processing capability, but they're very purpose-built to a specific application. And so that's where products like NPUs, like Hailo makes, and some of our competitors, which are really structured from the start for that parallel processing, and to be flexible enough to be able to be, so the weights and the connections can be updated as models are changed, to be able to run many types of models, many types of pipelines through a single device like a Hailo Edge accelerator. So those are the kind of four main types: CPU, GPU, FPGA, and the newest way, the most efficient way, in my view, is to run these on NPUs. So those are the kind of key technologies that we see as well. So now I'll talk a little bit about to bring those all back down to a couple of different examples that I think would resonate with the audience. So these are some of the key markets that Hailo works in, and I think as all AI companies would be focused on these type of workloads. So the first is security, and this is a very natural thought, right? So you have things like access control. You are determining from a scene, is this person permitted to come into this area, or has this person gone into an area they should not be allowed in, right? So this is taking visual data from a face or from a person, and deciding, making decisions from there. And if you extend that beyond just security, if you have, say, a large box store, a Home Depot or a Walmart or something like this, and you have cameras distributed throughout one of these installations, you can use those cameras not just for security, but also for retail analytics. So you can start to not just know who should be or should not be in a certain place, but you can start to look at the flow of the people that are going through the store, where they're lingering, where they're spending their time. And maybe you want to reposition your products so that you optimize for where people are spending their time in their store. AI does a great job at the edge to be able to provide you these analytics. Industrial automation is another key place for AI at the edge. Things like robotics and automatic optical inspection. Robotics are similar to an autonomous vehicle, right? It's got to navigate the world around it using vision. Sometimes you add LiDAR or radar into that, but primarily vision. And it's got to make decisions based on the environment around it. Automatic optical inspection. So you've got a production line that's running, thousands of units per minute across it, and you need to detect what's good and what's bad. AI does an amazing job of picking up at the edge, picking up patterns and detecting what is anomalous, what is good, and deciding what you should kick out of the process. We've already talked about automotive. Personal compute is another key area that we're seeing a movement, and this is accelerating towards AI at the edge. So this, many people saw the announcement maybe a month ago or so from Microsoft, where they've released a lineup of AI PCs. Well, what their goal there is to, if you go back to the ChatGPT example, right? ChatGPT is a large language model that has been run primarily out of the cloud. Well, if you're working with a PC and either you don't have internet access or maybe other reasons, you still want to be able to run these workloads, you need something that can run AI workloads. And so that's where we're seeing now a movement where the personal computers are typically had been leveraging CPUs. Now they're adding NPUs, neural processing units, or integrated neural processing units into their products so that they can run ChatGPT or Sora or any of these Gen AI models directly on the edge without having to rely on the Wi-Fi or the access to ChatGPT in these data center type applications. So that's a few concrete examples where we're seeing AI. Now I'll turn it over to Charlie, and I think he'll go through some of Advantech's view of edge AI and examples therein.
All right, thank you very much, DC. So this is Charlie from Advantech, and before I go into some of the examples that I have here, just want to quickly preface that from my perspective, the idea of edge computing, quite frankly, is hardly anything new. I've been with Advantech for over 20 years, and we have many applications, like, for example, just a parking lot that's part of an access control, where traditionally you use different methods, like you pull a card, you press a button, and then when you pay, you slip a payment into the system. Those are still available today, so it's not something that's kind of really ancient. But now, given the capability of AI, you have additional ways to collect payment. For example, license plate recognition that's associated to the account that you set up on your phone, and you can just pay the parking fee via your phone instead of having to reach out of your vehicle, try to access the terminal, and you may or may not be able to reach that far, so you end up having to open the door. So those are the things that the Edge AI actually is going to start to make an impact as far as making our lives easier. And some of the vertical market that from Advantech's hardware standpoint that we see actually starting to utilize Edge AI, the first one is actually healthcare. We have been in healthcare for many years in patient monitoring and many other different vertical applications. And what we do see, particularly in Edge AI for healthcare, is surgical. So some of the example that I share here today, the orthopedic surgery, AR spine surgery, advanced endoscopy surgical care, those are actual real applications that we're working with different companies that are bringing to the world right now. So for example, the orthopedic surgery, we have utilizing different sensors, cameras, analyzing the images that is captured by X-ray to help optimize the surgical workflow, to augment the image interpretation and enhance the surgical outcomes, and actually be able to maximize the clinical value from a technology investment, and in order to optimize the performance and outcome for both hospital and surgery center environments. So that helps the orthopedic surgery to become more successful. The augmented reality on the spine surgery will able to utilize the imaging to create an accurate 3D anatomy that allows the doctors to get those visualizations, giving them ideas on where to insert tools, how far do they need to insert tools, and to get a successful surgical outcome. As far as the advanced endoscopy surgical care, you have the end-to-end suite of AI-powered software. It provides the intelligent, data-driven patient communication and also real-time interoperative AI for surgical and analytic, and also feedback. Now, when it comes to surgical, when you include AI in it, as DC has mentioned earlier, if you, for example, let's take a look at the AR spine surgery. You're in the middle of a procedure. You want the computer to tell you how far you need to go. And as you go, the data goes all the way back to the cloud. Say, okay, maybe you should stop now, but with that delay, you're drilling a little bit too far. Now we have a serious health problem. So that's where system needs Edge AI, particularly for the surgical application, in this case, to make sure that there's a patient safety involved, and that's something definitely we do not want to mess with. Then let's take a look at the next example is security, which also resonates with what DC has mentioned earlier. And we have an actual real working relationship with Hailo right now in the security application. The application, quite frankly, is in the sense of object identification. Is security going through is going to scan your body, scan your belongings, scan your person, whether or not you're bringing anything dangerous, whether or not you're bringing something that is acceptable, is going to be able to quickly identify what you have, what's on your person, what's hiding on your person through various different technology ways of sensing, imaging, to try to figure out if you are safe in a certain location. And if you look at the lower right-hand corner, you got a guy in a public space holding a shotgun. Quite frankly, that's certainly not something that you want to see in person. And as far as the safety is concerned, that should be immediately identified, inform the authority or the security personnel to get involved and take care of the public safety concern. Then we also have facial recognition. That's another application that I'm currently working on right now, where facial recognition can actually use for various different applications, including access control, including marketing technology. So like if you walk into a store, it can recognize your face, you're the VIP, it can come up with your age, you can come up with your information if you're willing to share. So it's I know I'm veering a little bit away from the security application, but at the same time, it can be used for other purposes as well. Behavior tracking, whether or not the behavior based on the AI imaging, are you in the area? Are you holding a baseball bat going to the object identification? Are you breaking a car window? Um, all those can be captured, analyzed, and actually prompt immediate response. May or may not have the time to go back to the cloud, asking, okay, is this guy doing something that's sanctioned? Um, do I need to do something in the sandbag? If it's really nearby, can send to the authority and immediately inform them. Perimeter security is also another application that I do see where you can set up like for example, if you have a heavy equipment yard, you certainly don't want some unauthorized people rummaging through and try to steal things or whatnot. So are people where they are not supposed to be? Who is authorized, going back to the facial recognition? And as going to the next point, the worker safety, for example. If you are in a place where you have a lot of heavy equipment, you're working with something dangerous, you need to wear, in the construction site, for example, you need to wear your hard hat, you need to wear the reflective jacket. Are those workers wearing those protective gears? The worker safety part of the Edge AI application can identify those objects, whether or not they are being worn properly, and immediately notify the shift supervisor, hey, certain employees are taking off their hard hat in the area that they're supposed to wear it. So you might want to get in, intervene, talk to the worker to make sure that they're in compliance with the safety protocol. So things like that in the security applications, we see more and more edge computing with AI capability being implemented. Okay, and then, as DC mentioned earlier, there's the other one, and this is actually the heart of Advantech's computing solution. We are in the business of industrial automation since 1983. So we have a lot of application that goes involving with industrial automation. And one of the very important aspect is the inspection and quality control. Traditionally, it might require the workers to just look at all this product that's passing by and try to pick out what's not up to the specification. But right now we have several different tools available, including cameras, including sensors. The idea is the system now needs to have sufficient I/O to connect all those different sensors, different equipments, and that applies to all the other previous example as well. So we have camera to help detect the visual defects. It can be like the label is not printed properly. It can be one of the applications I have heard is in making of the cereal. So you have cornflakes coming through the conveyor belt, and the camera can actually detect which one is out of spec. And now you have like air pressure guns to blow those flakes out and sort them out. So that is one of the possible application based on edge computing. And once again, you certainly don't have the time to say, okay, the set flake needs to be taken out. The application must be deployed into the edge AI, is connecting to several different equipments to perform the proper inspection quality control job in a timely manner. And other things on the industrial computer, we need those IOs. And some of the IO that existed on the industrial computer is not available on the commercial computer. You look at the laptop these days, you talk about COM port. What is that? GPIO, what is that? CAN bus, why do I even bother to have that? But all those examples of industrial IO are actually very important in the sense to connect all the different sensors, different equipments to be able to control things like the air pressure gun that I mentioned earlier, the speed of how the conveyor belt is moving, controlling servo motors. So, and then control, say, for example, gates to open Like very often you see, particularly in agricultural food processing application, um, different size of eggs, different size of fish. How do you sort them? Those are being usually controlled by camera and then also the GPIO together at the same time to control the mechanism to send them to different sorting locations. Ethernet, Ethernet or wireless Ethernet, basically some form of a communication. Some from my understanding, there's definitely some machine learning aspect of it in regards to the edge AI. I mean, edge AI is not just to deploy what needs to get done. It also needs to be updated constantly in order to improve upon itself and help collecting data to feedback to the mainframe to assist the machine learning. So there's that feedback. Now in this, the wireless communication or the hardwire communication allows the system to continuing supply those data to the data center and at the same time receiving update to the deployment model as necessary. So we look at food processing, AOI inspection, and manufacturing quality control for different manufacturing application is something that we do see happen very often. So from the hardware standpoint, when you look at it, what is necessary to select a good edge AI computing as far as the common requirements? Scalable performance.
So, DC, let me give you a couple of questions to get started with here. And one of the things that as I was looking at this previous slide here, slide 10, is industrial computers have been around for a long time, and but I usually think of them as, if you look at this box, you see lots of I/O, and I usually think of those industrial computers as pretty much they're there to handle the I/O. How have they become more powerful? I mean, processors get more powerful all the time, but how has there been a big jump in the computing power that's going into industrial PCs, industrial computers, to handle the AI?
Well, so to focus on the actual compute power itself, that's a little bit more of a Charlie question. But when I think about what has been required at the industrial PC level to handle AI workloads, it's not really about increasing the CPU power. I mean, you can certainly throw more CPU cores at the challenge of AI and scale that up to be able to handle larger and larger workloads. But what you tend to be doing, as I spoke about in the first part, the architecture of a CPU is not by default designed to handle these kind of AI architectures. So you can scale up the CPU in a huge way, but you're probably going to be overspending for a CPU. What you really need to do is scale up your AI capability to match the AI workload or the types of applications that particular AI compute box needs to handle. So, and this is one of the reasons that I think Advantech and Hailo is a good pairing is we offer an AI accelerator that can be added on to an Advantech system. So you don't have to scale up your CPU necessarily. You can scale up the AI only and get really the right recipe of compute for the tasks that a compute or a CPU is well suited for. And then you can scale up the AI to match the appropriate level of AI that things like object detection and classification, like these types of AI workloads, you scale those up at the level that you need them. So it's almost like memory and storage. Sometimes those things scale up together. Sometimes you need more memory and you need more storage, but sometimes you need a lot of memory, but you don't need a lot of storage. And I think the parallel is the same for CPUs and AI. The workloads are different. The applications are becoming more different than ever. And so it's about getting the right recipe of CPU and AI compute.
I see. Okay. This is a
Sorry,
question.
I'm back.
Okay, Charlie, it's good to have you back. To our audience,
Hi.
this was Charlie's last slide anyway, so we're going to move into the into the discussion here.
Sure.
So,
Do apologize.
DC, you mentioned in your presentation, you talked about um, inspection, manufacturing inspection, and knowing whether something is good or something is not. Now, machine vision software and all of that, the whole machine vision um, industry has been around for a long time. So, how does bringing AI into that? How has that improved, or how does that improve the ability to handle to handle these possible defects?
Yeah, so things like, traditional machine vision techniques, I mean, you're generally looking for very specific characteristics and things around edge detection and problematic images around these edges and so forth. What AI is best at, or one of the things it's best at, is identifying patterns where we would not recognize the patterns, right? And so as you're getting to a point where you don't want to, like with traditional CV techniques, you don't necessarily want to train for every instance. Like you don't want to design an algorithm per every instance that you'll see. Instead, what a better approach to do is feed in a ton of data and let AI do what it, like I said, like it does best, and identify these patterns based on a lot of data that it has available to it to make these detections or make these conclusions. So it's less about, and this is the whole difference around training an AI based on a ton of data versus sort of a defined algorithm. With a defined algorithm, you have to have a person in the loop that defines what is good, what is bad. With AI, what you're relying on is an enormous amount of data, and for the AI to make different type of conclusions, different connections, but come to better conclusions about what is a defect, what is, or what is a person walking through a scene, right? So it's all about training on a bunch of data versus, pinpointing the exact algorithm that you have to write to identify the anomaly or the defect.
Charlie, so Charlie, welcome back. And the question is, the box that you showed a couple of slides back. Actually, let me jump back to that. So back here, you've got an industrial computer. It's got lots of I/O on it. It's got serial. It's got, this one's even got a DVI. You've probably got VGA on there. You've got LAN. You've got USB. You've got all of these things because you never know what's going to connect to it. How does this? But then you mentioned wireless LAN more for data collection and system. Would someone use this type of industrial computer with, say, a wireless IoT? How does an IoT and this industrial computing, how are they used together? And do you have applications that you might be able to cite to tell us about how what I'm calling IoT connecting to this type of computer?
Certainly. Say, for example, there is interfaces within the system that you cannot see from the outside, and typically in the form of like a mini PCI Express or the newer M.2, different type of keys for different type of application. We have available for like a Wi-Fi / Bluetooth, 4G, 5G connection. But from the IoT standpoint, you're probably talking about something on the LoRa or those type of low frequency but longer distance communication type of implementation. And we have applications or working on applications on things like detecting pressures within oil transmitting pipes or whatnot. So those can certainly be implemented into our power solution, just depending on the type of technology that's needed, what kind of wireless communication protocol needs to be implemented, and we can install the module accordingly to create that capability with our hardware solution.
Okay, so Are there any standards that come into play here? And I'm not talking about the communication standards. They're all well defined. But are there any standards in terms of, and it may be very much industry dependent, but are there any standards that our viewers should know about regarding industrial computing and such like that?
As far as the standard goes, I guess it's like you say, it's industry related. For example, if you're dealing with, it's like in the form of certification, if you will, there are, for example, E-mark needed for bus type. If when you're installing a computer into a bus, there is the certification. What was the IEC or oh no EM 50155 for railroad type application. There's the system IP rating. So there are many different standards not related to protocols, not related to communication. But when you're implemented, particularly industrial computer into more harsh environments, then there are all different type of a standard that applies to the computer that is necessary to survive in those type of environment. The most common type that we do have is not necessarily a standard, but more so just how hot is it going to be within the implementation. It's not always going to be nicely air-conditioned room. They might be outside for, it could be easily as an outdoor signage kiosk. It could be something that is needing to be in a warehouse with no air conditioning. So many of our computer, doesn't matter it's boards or the systems that we offer, just computing solutions, we offer those in the industrial temperature capability to make sure that you can survive the type of environment.
Okay, and some questions we've got some more questions coming in. So here's one. How much of an impact does the capture hardware, being lens, camera lens, resolution, and so on, affect the performance of computer vision related tasks? That is, how much can an AI accelerator tolerate with low resolution devices? Anyone want to try that?
I'll take that if that's okay, Martin.
Go ahead.
Okay, so in general, I mean, the kind of the answer is, the resolution, the camera type, those should be defined based on the task at hand. So for example, if you're doing optical inspection and you're looking for fine detail, you need a lot of resolution. You can use generative AI to simulate details, but if you're really trying to do optical inspection, you want a high resolution image. You don't want generated data, right? But at a high level, we also have, like in certain applications like security and others, where customers are designing or using very low-end cameras that already exist. Say, like they're coming in, they have a few very inexpensive cameras in a small business that are used for security. If you add on like an edge system from Advantech with an accelerator from Hailo, you can still get extremely good results from very low-end cameras. For detecting, where people are, where they should and shouldn't be. So the answer is it's dependent upon what you're trying to achieve, but an accelerator can get very good results out of a very low-end camera, and in some cases can use things like enhancing AI, improving the quality of the image to compensate for the fact that your lens or your camera is not the highest quality. So in some cases, you might be able to get away with a lower cost, lower quality camera with better analytics, which an accelerator could give you.
Okay, let's move into another section here, and this one's going to be for DC, obviously, but why Hailo? And then I'm going to have a follow-up question from the audience. But why don't you go ahead with that first, DC?
Sure, thank you. So again, there's kind of two main classes of or how how to think about AI. There's training AI and there's inferencing or doing inferencing with AI. So typically, training is done in a data center. We all hear about the enormous amount of power it takes to train up ChatGPT, et cetera. Hailo is not focused on training training models in a data center. What we are focused on are the highest performance, lowest power, or highest or best power efficiency, best cost efficient edge inferencing devices. So we're really purpose built to handle inferencing at the edge. We offer, very significant level of AI TOPS. So we haven't really talked about, tera operations per second, but that's really how you think about AI performance. So from just a straight AI performance perspective, we have solutions starting at 13 TOPS, going up to 208 TOPS and beyond, to give you a ton of capability for smaller workloads, smaller number of cameras, up to dozens of cameras or hundreds of cameras. So you've got a lot of AI to work with. You've got a versatile set of form factors to work with. We've got M.2, PCIe, E1.S. So in terms of flexibility and power, we've got you covered. The other thing that's critically important to any AI design is you want to make sure that you can actually bring and work with the models that you want to work with. And that's where our software, we haven't talked about software too much, but we make silicon, but the software that accompanies our silicon is really powerful in order to be able to work with any type of model that our customers want to work with. We have hundreds that have been ported to Hailo already, transformers and convolutional networks. Those are the two main types of networks that we see today. And so that software needs to be powerful, easy to use, and let you work with your models. And that's the other aspect. So from a versatility and a software perspective, I think we think that we're head and shoulders above the rest. So that would be why I would say why Hailo.
All right, it looks like it's my part. So why Advantech? We're in this business since 1983, as I mentioned earlier, and we are a pretty successful company so far in offering the widest variety of the product available when it comes to edge implementation. And that is the main reason that we have so many different available solutions. Just to give you an idea, we have single board computers with various different sizes, industrial motherboards, different type of systems as a general purpose system. That one of them you have seen earlier, those type of implementation was a lot of different IOs, allow connections to different sensors, different hardware solutions, and expansion capability as well if some expansion is necessary to add on GPU card, say from Hailo. We have mini PCI Express, M.2, or even PCI Express for the higher performance ones. And then we even have just a quick example here to show some very ruggedized design, designed to for very harsh environment. This one has IP65 and everything. Not going to go into the wee details, but as far as the vertical market solution is concerned, we certainly have additional hardware solutions that we can provide to the customer for their edge computing needs.
Okay, well, Charlie and DC, thank you for this informative webinar and for answering lots of questions. To those of you whose questions we didn't get to, we can still answer them offline. And if you're watching this on a recording, you can still ask questions, and we'll be able to get back to you with that. Again, thank you to Advantech and Hailo for this webinar. And just a reminder, this will be available on demand at eetrainingdays.com. For EE World, I'm Senior Technical Editor Martin Rowe. Thank you for watching.